Hello class, my name is Eric Hilliard, and today we're going to talk a little bit about calculating series and parallel circuits along with the benefits and negatives of said circuits, and also how DC circuits are used on aircraft applications. So the first problem that was proposed to us is you got a 12 volt source, and you've got three resistors, 50, 80, and 100 ohms. We need to find the total resistance in a series circuit. That's relatively easy, as you can see. You just add all three of them up. So 50 plus 80 plus 100 gives you 230 ohms. So speaking of ohms, there's a pretty smart dude named George Simon Ohms who discovered the relationships between current and electromotive force and power and resistance. Came up with a couple of equations. So one of them that he came up with is the total current relationship is electromotive force over resistance. So basically your total volts, in this case 12 over the total current, which I stated earlier is 230, gives you 0.052 amps or 52 milliamps. The next question was if 80 ohms resistor crapped out on us, would the circuit continue? And my answer is no. It wouldn't, because it's a series circuit. If you remove a resistor out of there, the circuit's shot. It's one way, one path, like Crane said, one path for the current to flow. So now we're talking about figuring out the total resistance for a parallel circuit. If all three resistors were of the same value, you could just take the value of one of the resistors and divide it by the number of resistors, and you'd have your total resistance. But in this case, because we have three different values, and we don't just have two, I'm using the equation RT equals 1 over 1 divided by resistors 1, 2, and 3. Adding the sums up and coming up with my answer. So like you see, take 1 divided by 50, added it to 1 divided by 80, added it to 1 divided by 100, and then took 1 and divided it by that sum, and that's what I came up with. Alright, now so we're talking about series parallel combo circuits. In this case, easiest way that I figured out to do this, thanks to our book, is just split them up in twos. So I took resistor 1, resistor 2, multiplied the values, and then divided them by their sum to get 71.4, and then same thing with resistor 3, resistor 4, and I came up with 127.3, and then I took those values, did the same thing, multiplied them together, then divided them to come up with a total of 45.7 ohms. Hope you guys found the same thing. Alright, talking about the good and the bad of series circuits, they can supply more voltage. So, if you have a 5-volt battery, or 3 5-volt batteries in line, you're supplying 15 volts, whereas if you just had, say, 2 5-volt batteries in parallel, if one supplies 5 volts for 2 hours, and two can supply 5 volts for 4 hours, stuff like that. Bad thing is that, like I said again, once one source, one load goes, in this case like a light in a Christmas tree strand, that's it, it's shot. The good and the bad of parallel circuits, you're offered a little more options when you have parallel circuits because they can go around, essentially around shorts if there's one broken. But the bad thing is good luck finding it because of the way the paths travel. Same thing with the series parallel circuits. You've got options for all the electricity to flow. You could still keep a direct current to a system, but then have it broken up into parallel circuits. That way, if one side craps out, then the other sides can continue to go. But again, the bad part about it is good luck trying to find the short. The use of DC circuits, DC power circuits, that power certain things like your flight, navigation instruments, cockpit cabin lighting, starting systems, and of course, most importantly, your backups. So usually your batteries, your last option, depending on what kind of aircraft you have. And that supplies that volts DC power to keep you afloat until hopefully you can find somewhere to safely land. So this is the end of my presentation. Hope you guys learned something just like I did. Sorry I ran a little long. Take care. Best of luck to you guys.